People often say technology will solve the world's problems. More specifically, that technology will solve the environmental crisis. This is a really reassuring thought. The idea that technology is the silver bullet to all environmental issues. However, have you ever stopped to ask yourself, how? Hello, everyone. My name is Rhiannon Szewczyk, and I've had the amazing privilege of working this past summer with Dr. Nost, researching the potential of digital conservation. In this research, we stopped to ask how. Specifically, how is technology impacting conservation? Digital conservation refers broadly to the application of technology in conservation. This includes everything from using satellite images to count elephant populations to planting microphones in the ocean to track illegal fishing. A major component of digital conservation is machine learning. Machine learning is a way computers can be trained to automate processes and come to conclusions with minimal human support. These technologies have the potential to make conservation efforts easier and more accessible, however, are not always employed. With this in mind, we set out to summarize and understand the conversation about digital conservation. We conducted a brief literature review, reading through academic journals in the field and writing an annotated bibliography. The majority of this analysis, however, focused on data accessed from Twitter. Using Twitter's research product track and keywords such as machine learning, conservation, and artificial intelligence, we were able to gather tweets that contained links to articles from the past 11 years. With these links, we ran a word count script that produced data on the number of times key terms were being mentioned. We also did a qualitative analysis of the top 500 priority articles in NVivo, keeping track of different projects and themes in the discussion. Our results were converted into average use and frequency of use of key terms. The average refers to how many times per 100 pages should we expect to see the term. The frequency refers to how many pages out of 100 have at least one mention of the term. For example, the key term algorithm in 2020 has an average use of just under 15 and a frequency of use of 5. This means per 100 articles scanned in 2020, we should expect 15 mentions of the term and 5 pages that use the term at least once. Many terms over the past 11 years have an upward trajectory. These include data, artificial intelligence, citizen science, and partnership. These terms are being used more often in the discussion about digital conservation. We also looked to see what data, if any, covaried. With this, we were trying to see if a specific technology was being mentioned more often with a given target than others. For example, the terms algorithm and decision-making have a slight positive correlation. Each one on the graph is an article with the X and Y axes measuring the number of mentions of decision-making and algorithm, respectively. This correlation tells us the term algorithm is being mentioned in the same articles as the term decision-making. After going through the data on the key terms and coding the 500 priority links, we were able to reflect on this conversation. The major promises of digital conservation are increased efficiency and new opportunities. Existing conservation methods, such as ground surveys, are becoming more efficient with the use of new technology, and processing data has become more efficient through machine learning. New opportunities are another major promise of digital conservation. This includes being able to track illegal fishing using satellite imaging. Camera traps, which take a picture whenever motion is detected, are also being used to be able to observe wildlife without the researcher's presence affecting the animals. This has allowed researchers to access images of wildlife previously inaccessible. There are challenges to implement digital conservation, though. A major one is the cost. Even when individuals in the field support these new initiatives, there still needs to be funding available to implement new technology. This challenge's impact, however, is decreasing as technology continues to advance and decrease in price. Another factor mitigating this challenge's impact is investment. Big companies like Microsoft and Google have been providing funding to digital conservation projects, as well as participating in research and development on new technologies for conservation. A second challenge is lack of knowledge. Conservationists and researchers often do not have the technical knowledge to use these tools. This challenge is being mitigated by cross-sector partnerships between tech companies and conservation organizations. Tools are being developed to be more user-friendly, allowing a greater application of these tools in the field. The promises of digital conservation outweigh the costs of implementing it. New technology is already improving the efficiency and reach of conservation efforts, and with continued funding and support, will remain a key part of conservation in the future. With digital conservation, technology is no longer an outside magical force, but rather a real tangible part to the solution. While the literature is clear that digital conservation alone will not be sufficient, it is another tool at our disposal for mitigating environmental issues.